Good morning once again. So let's get started. The topic for the webinar today is DevOps is more than CI/CD tools, and it's driven by the fact that I've seen most of the teams that are trying to adopt DevOps put a lot of focus on the tools that are used for CI and CD, and they have a sincere belief that they would be able to achieve their objectives by just implementing the tools. I want to do this webinar today to try and explain what are some of the other things that need to go in other than the CI/CD tools so that you are able to get your objective accomplished. So I'll quickly introduce myself. We'll talk about Digitave for a few slides before we go into the actual webinar and get into the Q&A. Because there is a fair amount of content to be presented today, we might not have a lot of time for Q&A. But if you do have questions, please do keep putting them in the Q&A panel on your GoToMeeting session, and we will try and answer them offline if we can't get them today as part of the webinar itself. So my name is Sudipta. Most people call me Sudi. Have been in the industry for over 2.5 decades now. I head the products function at Digitave, and I have in Digitave played different roles and responsibilities. I also look after the limited web societies in India today. We run 5 chapters, so if you are interested, please do go to the meetup.com forum and do register for the limited web society events. About Digitave, we are a pioneer in web-based collaborative product solutions for globally distributed teams. We are headquartered out of the US. Across our products, we have over 700,000 users, and they span right from traditional waterfall to lean Kanban, agile methodologies itself. Swift Kanban is our flagship lean agile product. We have Swift ALM, which is our enterprise ALM and process governance product, which has pretty much a leadership position in the Indian IT industry today. We have Swift Sync, which is our integration bus for our products to be enabled to work in an ecosystem of other customer tools. So that's our product suite with which we cover over 700,000 globally today. Swift Kanban is a product that is built on David Anderson's Kanban method. You can build a variety of templates and value streams and business models around it. It is meant for IT as well as for non-IT. We have customers who are using it in procurement, marketing, legal, things like that, as well as planning your personal events, whatever you might want to have. So it is anything that you want to do in a staggered value stream oriented fashion and be able to visualize and see that value stream. You can actually go ahead and Kanbanize it and gain benefits of flow-based execution. It comes with a whole bunch of dashboards. A lot of them will support your lean analytics initiative. On top of that, we have other custom metrics that you can actually build so that you can slice and dice the data the way you want it to be. A fairly global list of customers who are using our products today. They span across all the 3 product lines, and we have been around for 15 years. So therefore, over the last 15 years, we have built a customer base that is very diverse and spread around the world today. Some housekeeping rules. The webinar will be recorded, and therefore we will make it available to everyone after the webinar. As I said, we will take the questions via the Q&A box, and if we can't get time today to answer them, we will get back to you offline. So let's start with quickly understanding why DevOps. And from the first principles of Agile Manifesto, it says early and continuous delivery of valuable software, right? So therefore, the emphasis on the word continuous delivery of valuable software. So it doesn't help to just build software and have it ready for rollout. It doesn't make sense to go ahead and have it UAT tested and have it ready, or it doesn't make sense to just keep it build ready. it has to be in a state where it is continuously deployable, and so that you can go ahead and release it as soon as possible to your business user. So if you were to ask the single question that what's a KPI that you want to focus on, if this was your objective, the answer in most cases should be lead time. Lead time is the only metric that actually tracks the time from when the requirement or the request came to the IT side from the business and when it finally got delivered. So that entire cycle time is what you would focus on when you go ahead and if you go ahead and when you're delivering work to your customers. So keeping focus on lead time helps all customers, all aspects of the entire supply chain, of the entire value stream come together. So if you have multiple teams through which work progresses, which is the typical scenario that we would experience in any environment, then helping everybody focus on the lead time to customer helps people understand that yes, how do I need to make it happen so that the customer gets it fast, and then all other concerns become secondary to that single focus objective of the business. So how do we bring lead time down? If you look at the overall software lifecycle process that we have today, you would be essentially breaking it up into three boxes. One is from ideation to specification, including the front end, and front end today is quite fuzzy and a time-consuming process for most web applications. Then a specification to dev complete, and finally, once it's dev complete, to take it from dev complete to production deployment. The agile lean methods typically focus on the middle box. They're all focusing on they start from the point where the backlog is nicely groomed and it's prioritized and it's good to go, and they finish to say, okay, I have got software that is good to be released. But the actual process of taking it from that state and making the release is not part of most of the agile methods, whether it is Scrum or anything else we refer to. DevOps clearly extends that spectrum. So DevOps takes that focus and extends our horizon from the ops to the dev cycle, so that we can accelerate things that would typically be of concern during the deployment process, make them move to the left, make them happen up front, so that that part of the cycle can become early and smooth enough. So the point is, can we implement DevOps-based practices to make this process, which is the actual deployment process, a non-issue, put adequate processes and infrastructure to make it an absolute regular run-of-the-mill function. So if you look at the state of the DevOps report out of 2016, the 2017 report was just published a couple of weeks back, if I remember correctly. But if you look at the 2016 reports, the numbers are very compelling. The magnitude of the high-performing IT organizations, how far they were ahead compared to the low-performing IT organizations, the difference is very stark, right? So the high-performing IT organizations could do 200 times more deployment, could recover from failure 24 times faster, things like that. But what I think was most interesting and would appeal to any business person is the fact that that high-performing IT organizations that deploy these practices, they consume 22% less time on unplanned work and rework, and they create an employee satisfaction that is 2 times higher than otherwise. So if you have to sell the idea and sell the value of the agile DevOps practices to your business, if you actually talk about saving 20% plus on unplanned and rework and creating an employee satisfaction that is 2 times higher, you will surely definitely go ahead and get a lot of traction from your business. The other aspect which I think is very significant of this entire combination of agile and DevOps put together is that for a long time we were always trained and built to the thought that we are bound by the triple constraint, that these 3 constraints will pull us in different directions, and a project manager's job is to somehow get the right balance, because if you overstretch in one direction, something else will get compromised. So if you overstretch on time, scope will, or if you want to do too much of scope, you will compromise on time, so on and so forth. Agile methods and these practices, the DevOps practices, for the first time actually give us the opportunity to deliver the highest quality in the least time with the least effort. So by continuously delivering fast incremental changes, the triple constraint myth that was in our industry for donkey's years put together has essentially been proven wrong. And I think for anybody who has been through the cycle of waterfall in their careers would realize how potentially meaningful that is, because no longer do you need to go back to your customer and say, if you want more scope, you need to give me more time. You can now go ahead and tell him that, no, if you want more scope, I can go ahead and do it right now if you prioritize it, and I will take it up next and I'll get it delivered immediately. So what makes these high-performance IT organizations? And this is from the DevOps service practices survey report, and they bucketize it in two key buckets. One is continuous delivery, one is lean management practices. And what is striking is that the emphasis and the focus on lean management. Until now, there was a strong focus on the technical practices, looking at continuous integration, continuous delivery, things like that. But there is a very high focus on lean management practices now going forward, realizing that yes, in order to make the right culture and the right processes as part of the system, apart from the tools, we need to follow the lean management practices. So what about continuous delivery? Three things that make continuous delivery: test deployment and automation, continuous integration, and ensuring that all production artifacts are in version control. So if these three key practices, and we will talk a lot more about this today, if these three key practices go, you would go towards your journey of continuous delivery, and your journey of continuous delivery will lead you to a high-performance IT organization. On the same hand, if you actually implement WIP limits and do visualizations like board-based visualizations, and if you implement feedback loops, continuous feedback loops, then you would move closer to the objective of lean management and be able to foster yourself into a high-performing IT organization that is ultimately resulting in better organization performance. So today, IT has become a competitive advantage, and because of these methods where you can actually implement changes fast, you can focus on what you need to do, you can prioritize it right, you can visualize and see what would go next. All these put together would actually help an organization become more competitive instead of just focusing on business and some other objective. So why is this difficult? So fundamentally, if you realize, Dev and Ops come from two different perspectives. Dev and the business are focused on trying to get things done fast and move into production, right? At the same time, they assume that it would not create instability. It will not break things. It will be secure. It will still be high performing. So the Ops guy is trying to make sure that yes, whatever you're delivering is working and it doesn't break whatever you have done. And so over the years, we have created a whole bunch of ITIL practices around change management, release management, production operations, things like that, to be able to make this bridge from development to operations, right? So it's not that these two have very different ultimate objective. Both understand that what the customer needs, but both are focusing on two different aspects of the software delivery lifecycle. And therefore, the trick is to try and amalgamate them two as much as possible to try and see if the concerns of Ops can be moved to the left, to the development size, and a lot of the things can be done upfront so that the Ops guys can then go ahead and make your deployment faster and quicker without having to worry and knowing that yes, it has already been taken care of. One question that I'm often asked is that whether the ITIL practices and the certifications that we have built for over these years, do they need to be thrown out? And the answer is a most definite no, because these certifications and processes deliver a purpose. The purpose hasn't disappeared suddenly just because what we are doing in terms of lean, agile, or DevOps. So the important thing is to actually be able to pivot from what we are doing today and go to the next level in terms of turnaround on cycle time efficiency, so that finally business gets their needs turned around fast enough. So whosoever is into DevOps would have read the Phoenix project, and there are three takeaways from the Phoenix project. One is DevOps is applied Kanban, and to run DevOps well, you must understand Kanban. And if you recall, this is the section where the member of the board is explaining to Bill and trying to give him some clues as to where he should study more and figure out what to do next. DevOps is not a collection of tools. Nowhere in this book there is a big inventory of tools that you need to implement and therefore be able to get to your DevOps journey. If your people are 100% utilized, you are introducing waste. You will introduce waste. You will introduce constraints. You will introduce systemic waste where other people are suboptimally utilized because the constrained resource is 100% utilized. And that's your Brent in that example. So what's beyond CI/CD tools? And I will focus today on only one aspect, which is continuous delivery. We will not have time to focus on lean management practices and culture, but we'll at least try to focus on this side of the continuous delivery so that you get a fair exposure to what are some of the things that are happening and the practices that can be followed in order to be make continuous delivery a realistic objective. So what does always deployable mean? So it's the ability to get changes into production safely, quickly, and sustain it. So the important thing is not to do it one time. It must be something that that becomes so part of your DNA that it is a non-event within the organization. And to make that happen, whatever you make, whatever you build, should not just be functionally ready. It should be ready with all the non-functional requirements that go along with your application. And if you are able to do that, then there is a significant amount of cycle lead time that you can actually reduce from your overall software life cycle. The percentages would vary, but the fact remains that whatever is the time that you took earlier to be able to take this release and put it to production, you can significantly cut it down by deploying these practices. So how do we get there? And the first thing that we need to talk about is quality. And when we talk about quality, the first source of quality for today's world should be Deming's 14 points on quality management. And I have this spread across 7 slides. I've kind of highlighted the ones which have direct impact, in terms of what we talk about within the Lean Agile community. But most importantly, Deming from very early on held the fact that we need to build quality into the product in the first place. The earlier concept was that we would build and then we would do sample inspections to be able to see, are there non-compliances, are there things that are away from the tolerance limits. Deming moved away from that principle and said we need to build quality into the product in the first place so that we can eliminate the need for that sample inspection and going for corrective measures from there. And that goes right into our thinking of TDD and test-driven automation and writing test cases by the developers and things like that. Similarly, he talked about break down barriers between staff areas, remove barriers that rob people of pride of workmanship, and making sure that transformation is everybody's job. It is not just a job of one group or one team, it is everybody's job. So a lot of that we talk about within the Lean Agile community actually directly comes out of Deming's work that was put at least 30 years back. And yet our reference within the community to his work is quite marginal. What does it mean to us? It means that frankly there is no agility or DevOps with bad quality code, because if you're building bad quality code and even if you manage to make continuous delivery happen or reduce your cycle time, you're only releasing bad stuff more frequently to your business, and that absolutely would make no sense. There is no agility or DevOps with manual test regression about days, weeks, and months, because this cycle goes for a very extended period of time. So if you have a manual test repository and you take a month to do that, you would do a cycle 1, then take some time to fix that cycle, then again resubmit it to testing, and then take a cycle 2, and again do another set of testing and again fix it. And you might need 3-4 iterations by the time you would consider that as release worthy. So the minute you're talking about manual test regression cycle, you automatically know that you will not be able to achieve the objective that you're seeking. There is no agility or DevOps with Dev and Ops in their own cocoons, and that comes from the Deming's principle that break the barriers between the teams that ultimately cause the delivery of the value to the customer. And last but not the least, developers should be writing tests. If you don't have this, you're not ready for DevOps. The whole premise that somebody will do the development and somebody else would actually test for it fundamentally means that you will have a situation that you will never have adequate code coverage. You would always be reliant upon some scenarios not being trapped and not being captured that only the person who is developer knows that yes, he's built for and is and he's put that validation in place. So what to do? So the first thing is to treat tests as first-class citizens of a project. So just like you would use processes and tools to manage your source code, you need to treat testing and your testing artifacts the same way. I'm not going to get into the agile testing body of knowledge here for the sake of time, but for people who are used to an inverted testing pyramid, it is a non-starter. If you have a situation where you have a dedicated testing team which is doing automated testing and your development team is not doing automation, you will end up in a situation of an inverted testing pyramid, which would not have adequate test coverage, which would be extremely time consuming in terms of runtime. In effect, neither would you have quality nor would you have a cycle time reduction. You might get improve over where you are today, but you will definitely not be in the right path to create your continuous improvement journey and keep reducing the cycle time. If anything, it will only become a further impediment in your process. Revitalize the tester. It's a role, it's not an individual. And use the testing team people to do manual testing, to focus manual testing in specific areas. And that feeds into the very next slide, which is Brian Marrick's testing quadrant. It very nicely summarizes what all we can automate and what all we cannot automate. So anything that is testing related to support the development of the programming tasks that we have done, we should be in a position to automate it and we should automate it. But anything that is related to making sure that the requirements that have been built and are working, do they meet the final requirement? That will continue to be manual. That will continue to be domain-centric, expert-focused. So you would need usability testing, exploratory testing, domain-centric testing in that bucket. The only good thing is that's a very small percentage compared to the amount of testing that you typically would land up doing for ensuring that you have built the software correctly. So I think the Brian Marrick's software quadrant is a very nice reference to kind of understand what should be automated, what could be automated and should be automated versus what cannot be. And therefore, many people often think the testing function will be eliminated. Testers would have, would they lose their jobs because of lean agile introduction? That clearly isn't the case. But yes, they would need to strengthen their understanding of the domain of the product of the application of the end user requirement so that they are actually able to provide value which is just beyond making sure that the code is built right. The other aspect that we want to talk about when it comes to quality is test data management. And the core message that I want to give here is that avoid using DB dumps. DB dumps are time consuming, and once again, they will not have all the tests. They may not have all the test data scenarios that you want to cover as part of your coverage. In contrast, what you should focus is on building scripts that build your data incrementally. And that fits very well with your test automation strategy, right? If you're actually building test cases that have been automated from scratch, then you can actually, as part of the process, build data that covers the early life cycle scenarios of the business, and then those generate data to be able to test the later life cycle scenarios of your business. So it's a smooth flow that you can do using scripts and building data that way, instead of just focusing on trying to make sure that, yes, I just have a DB which is huge in scale and size. There would be areas like staging and performance that would be relevant, but largely for functional testing, you should build your test data. So a deployment pipeline would look like this, which is that you would have a delivery team that actually does a check-in. When you does the check-in, it will trigger its own local end testing. From the local end testing, if it all looks good, you would move it forward. If not, you would fix it and revert it. It would go to the acceptance testing environment. And once it goes to the acceptance testing environment, that's where if it works, you will move ahead with your manual testing environment. If not, then clearly the developer and the tester would need to do a triage to come and understand whether the code is built wrong or the test case needs to be modified because some part of the business has changed. So you need to be able to do that in a staggered fashion. The important thing is to ensure that you do this in the sequence, because if you don't do in the sequence, you are running the test environments which are to the right of the cycle take longer cycle time. So you need to make sure that the ones that take shorter cycle times run successfully and cleanly before you move to the longer cycle times and create waste for the system. So everybody knows acceptance testing. It's been there and we have talked about it for 50, 60, God knows 70, 80 years. But the fact remains that it is very hard. Writing good acceptance test cases is hard. I've seen enough number of projects and teams which have fairly vast acceptance test suite repositories, but yet they still have a fairly high defect leakage rates, which just means two things. Either your code coverage is not good, or you're not catching the real life scenarios that you're encountering in the field. So every time you get a failure, it gives you an opportunity to plug that gap, to be able to go ahead and put in that script so that both acceptance or testing or your unit testing, whatever be that level where that failure was introduced, it can get trapped and you have closed the loop, close that bug for good for the rest of the life of that application. Acceptance test suites are hard to maintain. They decay over time just like code. So now, because just like you have code repository, you will have a test suite repository, and that will decay over time as application moves forward. So you need to give it the same level of diligence as your production source code. Flaky tests are no good. I've seen time and again that people go ahead and land up in a scenario where they are writing, where they have an acceptance test suite, and they would do the run, and then they would say, well, I'm not sure. There are, yes, there are some test cases that sometimes succeed, sometimes fail. That situation is very, very flaky because it doesn't give you the confidence. So what you need to do is to move them out into a separate repository and refactor them separately, so that at least you know that what I have is a clean repository and I can rely on it. If from there, if I have a failure, I know that something is broken and it's not good to move forward. Okay, so if you have flaky tests, take them out and move them into a separate repository. If you have systems that work in an ecosystem of other systems, then before you submit them to the full acceptance test cycle, make sure that you have tested in a separate cycle, in a separate shorter cycle, tested the integration points. That's where your maximum failures would happen. And clearly, if that point is not, if that doesn't succeed, then clearly your longer cycle acceptance testing will also fail. So therefore, it's important to make sure that your external systems are tested first ahead of time, making sure that your integrations are working and your APIs are live before you go into the next stage. Browser-based testing was the recommended method for a long period of time, but as time has progressed, the thought cycle has changed there to the fact that it's essentially time consuming. You're always waiting for the server to send you a response and then for the browser to react and take you to the next step. So what we are recommending today is that one should move into into journey maps, which are nothing but an extract from the acceptance test cases. You're not building this from scratch, but you're moving from a browser level testing largely to a server-side testing. And if you have written the application largely using services based, then you can write the complete journey of the user calling from one API to another entirely on the server side. So, and if this server-side test scenario execution path goes correct and that goes well, then you can do a smaller and a shorter front-end cycle run using Selenium or whatever other whatever other product that you have to be able to actually make that cycle fast and efficient. So the more, in summary, the more you can test using on the server side using APIs, the faster the cycle time would be and being able to fix it. Keep curating your tests. One of the big problems that I've seen in the Agile community is that because we continuously keep building stories incrementally, we keep adding incremental test cases corresponding to every story, but we very rarely go and refactor the original test repository or the test case that we might had for that epic or for that for the story to be able to factor in that incremental functionality that we are now releasing in the most recent release. So it just explodes the test repository. Again, it takes time. So the more and more efficient we keep our test suite to make sure that it is efficient, it focuses and it gets the objective done and tested with the least amount of test cases, with the least amount of test data scenarios, the better it is for everybody's cycle time focus. So having spoken about quality, let's move to another aspect, which is the architecture and the design. So I think everybody would have heard Conway's law, which is that applications often tend to take structures and get designed in a manner that replicates their team structures, right? So if you have 4 modules working in one team in one location, in all probability they will be making direct calls to each other without worrying about anything else. And only if the 5th module is outside sitting in some other vendor team, then you would worry about, okay, let me go ahead and build an API to be able to do that. And Rebecca Parson from ThoughtWorks actually puts it very well. If you don't want your product to look like your organization, change your org or change your product. So the only and the best way to get around this problem is to actually have APIs. So every team communicates with every other team using an API, and that's the essence of the traditional SOA-based architecture, or even the microservices architecture, which is nothing but just a small extension to say that services can be independently deployable. But if you go beyond the definition, we have talked about services-based architecture for a very long period of time. Yet the fact is that you don't see its prevalence and its dominance across the industry. And for that reason, Amazon, Jeff Bezos actually, as way back in 2002, gave a directive to all its development teams, which in effect was that everybody would work with every other team using only through interfaces. And anybody who doesn't do that would essentially be fired. And he actually hired a bunch of very senior executives, if I remember correctly, the CIO from Walmart included, to actually make sure that this directive was followed through. So everybody had to write in APIs and everybody had to strictly communicate only through APIs. You could not just write to the DB directly or query from the DB directly just because you knew what the data model was. The other thing which Amazon did pretty early, and that's pretty significant, was that every team that owned the web service was responsible for its development and was responsible for its operational support. So the idea was that only when you go ahead and support your people for the service that you have built, would you appreciate their problems and their real world situation challenges. So as this quote says, that the customer feedback loop is essential for improving the quality of the service. So as early as in 2006, you see that Amazon had blurred the lines between between dev and ops. They made sure that people who are building a particular service are responsible and for supporting their customers who are using that service. And that was the best way for them to make sure that the service gets moved further and further strengthened. We'll talk about a few design patterns for some specific points of failure. The first one is for remote applications. So one of the most common things that we use for remote applications today is a circuit breaker pattern that essentially, so you build a wrapper that would keep testing whether the remote application is still live, and if it isn't, then it will time out and make sure that it will send you a message that yes, that the remote application is not live, and therefore it will not make the continuous calls to them. And then once it is live, it will actually go ahead and inform you when it is live, and then you can carry on and complete the rest of the sequence of all the pending calls that are left in the queue. Netflix has a very good open source tool. It's called Hystix. For people who are interested, you can Google for it. But it's a pretty nice package out there that you can use in our applications to be able to handle external applications. The other big challenge is for people who are actually doing legacy applications, and because they are not built using the modern day practices or the modern day design principles. So the method to go around that is to actually build strangler applications. So every new functionality that you are required to, you start building it in new incremental modules, which you are using the right practices and the right design patterns. And slowly over a period of time, these new modules take over from the original product completely, from the original application completely. So the analogy is used to these banyan tree vines, where actually over a period of time, these roots take over, and the original trunk is kind of rendered useless or dead over a period of time. So, and if you really think about it, it's the best way to make sure that you are able to refactor an old legacy application. You're not, you don't make a big bang project which nobody knows when it will get delivered and whether it will eventually succeed. The important thing at the same time is to recognize that any application that I'm building today will become a legacy application in a few years from now. And therefore I have to write it in a manner that I can actually enable it for the strangulation process to happen. And once again, that's where your services-based architecture comes into play. Because if you follow that, then you can very clearly substitute one service with another package using the service, and then say, okay, now I can make that old code obsolete and carry on with the new package for this current specific API. The third thing is that we need to architect for recovery. There is a very strong message that is often given in the DevOps community, which is that don't leave your build broken. The fact is that even the high performance organizations will have failures, and as high as up to 15% if you go by the DevOps survey report. But the important thing is that they can recover in less than an hour. So the most important message that I would say is that if you have failure, the first thing to do is to restore. Because in most cases, if you're trying to make a fix at late night at evening time, when people are tired and they're ready to go home, in all probability, either you will create another point of failure, or you're going to create a technical debt which will perhaps never get resolved. So the first thing is to create an architecture where you can actually roll back and create a mechanism for rollback, whether that is in the DB, whether that is in the front end. And that would be a success to make sure that you have actually an application where you can deploy something and roll back pretty fast. So what we want to focus on is optimize for mean time to restore service, all right? And if you look at the 4 steps that would typically go across any part of this cycle, so how can I detect, how can I find the cause, how can I fix the problem, and how can I roll out the fix? Out of the 4, only the third one you perhaps cannot put automation and instrumentation in place. For all the other 3, you can actually go ahead and put instrumentation and automation in place so that you have significant reduction in MTRS. So we talked about quality and architecture design. Let's talk a little bit about continuous integration. So I think most people who are perhaps on the session today understand continuous integration. But I think the main thing that I want to focus in this session is this, that everybody commits to the main line every day. Because too often what we see is branches where people have just spawned on the branch and they're happily continuing on their development, but neither are they pulling back from the main trunk on a regular basis, nor are they pushing back to the main trunk on a regular basis. And as a result, what you're doing is, as you're increasing the risk, because you're working on a branch with all sorts of incompatibilities with which others are working on. And as this practice expands, if you have medium-sized, large-sized teams, this negative aspect completely explodes, right? Because everybody is working on their own branch in their local environment and nothing is coming to the main line. So you have a massive problem on hand. So the message is, say no to long-lived branches. It is really needed, and it drastically diminishes in value over time as that branch ages over time. And the way to do around that is to actually use toggles. And toggles have been in the practice for a fair amount of time, but yet there are many teams that I see where toggles are not used today. And you can use toggles for pretty much everything, right? You can use toggles that are for releases. So let's say if you have a feature that's fairly big and you're working on, but you know it's going to be released 3 releases down the line, you can put a release toggle to make sure it is in the main branch, it is getting into the code, but it is not switched on till that release that you're ready to roll it out. Experiment toggles, and we use this for A/B testing to actually control the functionality for one group versus another group. Ops toggles, if you have a situation where you have performance reports or something else which is a very heavy processing application and you want to switch it off when you do anticipate a heavy user load, then you can use these ops toggles to ensure that, yes, I can dynamically switch off a particular aspect of the application so that the user doesn't experience any load. And permissioning toggles, which is similar to AB, but I will talk about it a little more, which is when we come to the use of canary releases. So the point is that we can use toggles to do almost everything that we're building, and have the confidence that even if our code is not ready for development, even if it is a very initial state of development, we can actually keep checking it into the main branch, use a toggle, and keep it switched off till we are ready to do it, till we are actually ready to make it production worthy. Now, toggles can essentially have can essentially be plotted on a longevity versus dynamism plot, right? So if you have toggles which are only a short duration nature, then you can largely keep them as static toggles and you can manually control them when it is switched on and switched off. But if you have toggles which you will need for a long period of time, because that's the nature of the applications, a good example being the ops toggles, then you would need a dynamic pattern to be able to switch on and switch off at runtime using other mechanisms. So toggle routing can be done statically or dynamically. Statically would obviously is an easier and a simpler method, and you get, if it's part of your version control, you get all the benefits of having infrastructure under version control. You would know any point of time what are the toggles which are actually working and which are the toggles which are not. So that's the benefit that you would get there, right? But the important thing is to realize that feature toggles would add to testing complexity, right? So for every time you have an on and an off switch, in theory you're testing for the on scenario, and in theory you're testing for the off scenario. Yet, if you analyze a bit, you can build in some efficiency around it. Again, the important thing here is to realize that at any point of time, you should be able to see and runtime generate which are the active toggles at this point of time in your system. Because if you don't have, once you introduce this mechanism and everybody starts using it, you will see a large number of toggles in the system, and everybody is using toggles without having a good governance and a structure. So put a good governance and structure around it and create a simple routine that will tell you at runtime in any environment which are the toggles which are active or inactive. And toggles do come at a cost, because at the end of the day, they are meant to serve a particular purpose. When the purpose is served, they need to be removed. Correct? So if you're having release toggles, you need to make sure that, okay, I give it a shelf life, and if once I cross that shelf life, the toggle is specifically removed. So what you need to do is to perhaps even put a small logic that we say that if there is a toggle which is in the code which is expired its shelf life, then I would make that build fail. So if you put something as rigid like that, then the team gets into the discipline of removing toggles on a continuous basis, because they know that the build will catch it if they don't keep a track of it and remove it themselves. So we talked about CI, we talked about branches, and the need to have short-lived branches where we are continuously checking into the main line every day so that everybody is in sync with what others are doing in the team, and you don't create a lot of integration incompatibilities. So let's move to deployment. And I will move relatively fast here. We'll talk about a few patterns of deployment. The first one is around DB, and the challenges of DB is that DB changes are often not, it's not easy to roll back DB changes. So the way to do this is to make sure that the new change coexists with the old change, and you would write to both the new and the old database fields, and the read access is written in a conditional manner. So you will check whether you will first check whether the data is in the new address fields, and then if it is, you will use that. If the data is not in the new fields, then you will go ahead and pick it up from the old field. This method is also, this pattern of deployment is also called dark launching, where you essentially first put the DB change out to production, and then once you know that yes, it's good to go, then you will go ahead and release the front end related to it and make that roll out that. So if you do this way, then you know that when the front end is going in, the back end is already in place and it is tested and it is stable and it's working, and you've de-risked any failure points from the DB side completely. So there is a fair amount of methods and practices you can put around the DB itself. Make sure that all your DDL and DML scripts are part of the version control and they run in a sequence. The important thing is to always build the DB from scratch using these scripts. Only then you will have the confidence that yes, my scripts are complete and I have not introduced changes which are not there. There's a nice little tool called dbdeploy.com that's also open source that you can actually, that will keep track of what scripts have run in which environments, and it gives a complete log of whether something has failed in which environment. So when it comes to DB, as I said, use a pattern called dark launching, where you roll out the DB changes first and then in a separate release go ahead with the front end changes. Number one. Step number two would be to put them into scripts and then make sure that you regularly scratch your DB and build the DB from scripts so that you have confidence on those scripts that yes, I have not missed or dropped anything. The next pattern there I would want to talk about is called blue-green deployments, and they have been around for some time. Amazon, Facebook, all of them use it. The basic idea is that you would have two almost similar production environments. One is the live and the other is the staging. So when I'm ready with the change or the incremental functionality that I need to roll out now, I'll put it on the staging and make sure it's all hunky-dory. And once it is, I will change the router to now point to the staging environment. And when I point this to the staging environment, then the environment which was live would now become my staging environment. And I keep doing this flip regular basis so that at any point of time, I always have one live environment and one staging environment to which all the writes are always happening simultaneously, but the read is only changing in direction. Okay. There are some mechanisms, I mean, while I just introduced the concept, but if you have live transactions, there are some, you have to look at individually to understand how to handle a live transaction when you are ready to move from one environment to the other. So depending upon your nature of application, you can figure out some patterns of how to do that. The very important thing to highlight here is that release is not equal to deployment. So when something is good to be deployed, you can deploy it to all environments. But whether every user sees that or not is a separate function, and that may be yes for some people and maybe no for some people. So Facebook uses something called a gatekeeper for this mechanism, for which they call as canary releases, which essentially means that a new feature is first released to a small set of internal users, which is heavily monitored for functional issues or for performance issues. And once it is confirmed that yes, it's good to go, then they actually may make that available to all other users. So once again, the important thing to state here is that just because you have deployed something doesn't mean that it is released to everybody. You can have a feature functionality that is available in every environment because it's fully tested from your point of view and it's good to go. But whether you enable it for everyone to see it or not is something that you have it in your control and you keep it. And that process is called the canary release process. So we talked about quality, architecture design, continuous integration, some of the deployment patterns for making a smooth deployment. Let's talk a little bit about infrastructure. Right. So the first thing when we come to infrastructure is to be able to define what a particular environment is and for, and how long will you retain the environment. The problem that I've seen is that once your ops and tools, and these guys are very shell script savvy guys, because everything is virtual, very soon you will have an explosion of environments. Everybody would keep asking an environment for a particular feature, for a particular customer testing, customization, for a particular stress test that they need to do. You will very soon have an environment situation where you have a plethora of environments and they're all coexisting at one point of time. You don't know what version has gone in where. It's a fair amount of nightmare that you can land up into. So the important thing is to be able to put some governance practices in place, make sure that you know what is out there in which environment, and once the environment's use is done, be able to close that and remove that environment. All environments must be built from scratch from your tools, and if you use any tool like Puppet and Chef, you can do it completely today. The very, very standard functionality is there. The idea is you need to don't get in the habit of taking an environment and replicating it, copying it into another environment. You must build it from scratch, because only then you have the confidence that your scripts have everything that you need to set up an environment. Only then will your team members know that if they don't put anything in the scripts, it will be a point of failure. So you must ensure that you protect yourself from what we call as configuration drift, and you are building environments from scratch using your scripts. So this is an interesting case study which was done, and it's a tale of two Web 2.0 startups scaling to 20 systems during their first 3 months. The first team starts writing software and installing systems as they go, waiting to deal with the ops stuff until they have an ops person. So they're doing it on an as it comes along approach. The second team dedicates someone to infrastructure for the first few weeks and ramps up from there. And you can very clearly see that they don't need an ops person for a very long time and can only focus on building new functionality. So if you get your installation and ops right, you can actually save yourself a lot of subsequent time from focusing yourself on this kind of activities. So here's a comment from Jesse Robbins. It says that once this is done right, it can bring your install time nearly zero, and it requires no specialized knowledge because the infrastructure is all in place. The other aspect of infrastructure automation is to test for failures. And Netflix has something called Simian Army that some of you might be familiar with. Essentially a set of tools and utilities which goes around simulating points of failures. So they would either take down a router, they would take down a data center, they would add latency in their APIs, they would do different things on a continuous basis that teams have to survive against. So now the dev guys know that I have to write my systems in a manner where I cannot assume that this infrastructure is working and in place. I have to build it for a manner where failure is part of the business. The same thing is done on Amazon. The same thing is done in Google today. All these large organizations test for failures on a regular basis. The important thing is that they build, it changes the culture. We were all built in a culture where we designed systems in a manner that failures would not happen. And if by chance a big failure happens, then heads would often roll. We are moving from that culture now to a world where we are saying that, hey, we would work in a plethora of ecosystems, all of which will not be in our control. And therefore, we need to make sure that we can survive any points of failure if it were to happen outside. So Netflix hosts its complete infrastructure on Amazon. If Amazon goes down, they can't go to their movie watchers and tell them that, hey, Amazon went down, therefore we are very, very sorry for your network outage, right? So they need to build to ensure that if one data center is down, they can get the feed from somewhere else, knowing exactly where that movie was for the specific user at that point of time, and he doesn't see a disturbance. So this pattern of usage is called resilience engineering. It's been there in the aviation and healthcare industry for many, many years, but we now see it coming more and more in our industry by these kind of leading edge companies into our domain. A few other thoughts that I think should be, before I end, developers should be able to run acceptance test cases on their environment. So make sure that the full configuration is there, that they can, where they can do their full cycle of tests. Virtualize all environments. If anything fails, stop the lines. As I said, that don't land up building a huge plethora of configurations. If you recall back to the Phoenix project book, there is this guy Brent who becomes the constraint, right, on whom everything is dependent upon, and you need the Brent to be able to do that job. So don't land up creating your configuration management Sherpas on whom you are dependent upon at the time of deployment or rollout. Okay. Also, when you're doing a lot of these tools deployments, you will get a lot of feed and a lot of continuous streams of data. You need to build some parsers that can actually focus on things where your true errors are, and you can then log for them and focus on those instead of having to look at them. Also put them all in one stream. In Digite, we have all put them into Slack so that all our tools keep sending all the logs on Slack, and then we pass from there and we report any genuine failures that actually come. So in closing, think lean, shorten lead time by focusing on the full value stream. Don't look at Agile and DevOps as two different initiatives. They are part of the same initiative, and that initiative is to reduce cycle time, lead time for your business, for your end user. Initiate small changes, take a Toyota Kata approach, avoid using the buzz terms, think of services, try to use services for everything that you build, don't call anything directly, and last but not the least, simulate and test for failure, security, and performance, because these things will happen. It's a matter of how to be able to restore it and make a seamless experience for the end user as much as possible. So with that, I want to end the session here. If there are any questions, I will. We are pretty much done short of time here, but if there are any questions, I will try and take some of the questions. Let me just give me a second. Yeah, so the questions were about, will the recording be available later? Yes, I said yes, and I think those questions are all answered. So thank you, everyone. Thank you for your time, and we hope that it was valuable. We will make the recordings available, and the marketing team will get back to you. Thank you.